Hello friends, I am Professor Suresh Sarola from Department of Electronics and Communication, Marwadi University. Today in this video lectures I am going to discuss about the multiplexer, the demultiplexer, the encoder and the decoder. Let us start with the concept of the multiplexer. You know about these things. These are the applications: the MP3 player, laptop sound card, digital satellites, cable. There is only one output, that is a sound system. So any one of the applications can able to connect a sound system. So I must require a multiplexer. That means all these four wires are connected to the input side and there is only one output. But when you connect this all the fours together, which sound will go to the output side, that you will decide. That means you must require a selection line. That means that if it is two selection line, the reason is if it is 00, MP3 player sounds will go to the speaker. If it is 01, the laptop sounds will go to the speaker, and if it is 10, satellite sound will go to the speaker, and the 11, the cable TV sounds will go to the speaker. That means this is the input, this is the output, and you have over here we call as a selected source or selectors. The another name of the multiplexer, also called as the MUX or MPX. Here, this selection line is nothing but a work as a switch. That means the outputs are connected to the one of the input through the switch which is selected by the data selections. So let us suppose consider there are the two inputs and there is a one output. That's why we call as a 2x1 MUX. That means two input and one output. Now here there is only one selection line, because if it is 0, I0 will go to the output, or if it is 1, I1 will go to the output side. If you write here the A0, I0 will go, A1, I1 will go. If you want to write it like truth table, whenever if it is 0 at this condition, that means what should be the value of I0 will go to the output. That means whenever A value is 1, that means what should be the value of I1 will go to the output side. It's same as like Q, I can write as a S dash. That means selection line is same as a dash according to our switch. The A dash I0 plus A I1. That means if it is 0, it will select I0. If it is 1, it will select I1. So this is based upon this you can able to design a logical circuit using the gates. Let us move toward the further multiplexer, that is a 4x1 MUX. Again, when it's 4x1 MUX, you have the 4 inputs, one always be output, and there is a 2 selection line. Based upon the input and output, I had drawn like A and B. I will get the output according to the selection line. And let's suppose take in one case here 1 and I1. Output must try the D3. That means but the 1, due to this NOT gate, this will be 0, this will be 0. If it is here D3, this will be my D2, this will be my D1, this will be my D0. This one is coming from this V1, so this is 0. And you know about this AND gate, one of the input is 0, that means another input is also 0. This is also this line 0, that means a 0. Here due to this line is 0, output of this AND gate is also 0. Here it connects with the 1, and here it also connects with the 1. That means 1 1 D3, output will be D3. If you do the addition of the OR gate, a 0 plus 0 plus 0 plus D3, what is the output you will get? You will get a D3 as output. Okay, so this is not, this will cause a 4x1 MUX. Now let's suppose consider there are so many possibilities: 8x1 MUX, 16x1 MUX, till 2 raised to n to 1 MUX. How you will decide how many the input line, what is the output, and what should be the selection line? Now here Let us take the example of n cross 1 box. So 2 raised to n inputs. So how many are the selection lines? N. Okay, let's suppose consider the 4 selection line. What should be the input? 2 raised to 4, and output will always be a 1. Now let us understand the concept of a demultiplexer. Here I have one computer. Okay, and the computer need to send a one printed data to any one of this. Like suppose I have a laser printer, fax machine, color inkjet printer, and the pen pointer. So anyone will take the data of a computer to print that data. Again, I need a demultiplexer. Okay, here, but how will this wires are connected to one PC, and these are the outputs are connected to different printers. This data will go to this printer or fax machine or color inkjet printer or pen pointer decided by this selection line. That is what we call as a, if it is 0 0, if it is 0 0, the data of computer will go to the laser printer, and if it is 1 1, the computer data will go to the pen plotter. Okay, so this is the concept of demultiplexer, which is reverse than multiplexer. Let us talk about the 1 cross 2 demultiplexer. Another name of the demultiplexer we also call it demux. Demux is a digital switch with a single input and the multiple output. Same what we had seen in the multiplexer, it's a 1 cross 2. So it always be like 1 cross 2 raised to n, and what should be the selection line? N. Okay, so based upon this, if the selection line is a 0 0, input is 0, it will go to the output 1, and if it is selection line is 0, input will go to the output 2. Again, if the selection line is 1 and 1, input will go over here, and this will go over here, the output 2. Based upon this truth table, you can able to design a logical circuit. Let us discuss about the 1 cross 4 demux. I have 1 inputs, 4 outputs, 2 switches, and that controls by a selection line. So if it is 0 0, output will be given, input will be sent to the output A. 0 1, input will be sent to the output B. Likewise C and D. If you combine, let's suppose take an example. Let's suppose, let us take over here the B, let us take over here A, and B equal to 1, A equal to 0. If it is 1, due to that is 0, and A equal to 0, due to this it is 1. Now due to this circuit, this will be the 0 and this will be the 0. So both the outputs are 0 0. Now here, for this case, this is 0. So get the output as a 0, and again this will be the output as 0. Now for this it's a 1, and for this it's a 1, and this is what the input. So here same as a f I will get, that is a b. If f equal to b, I will get, that means 0 1 input will forward it to the second input. Same as a demultiplexer, I have 1 to 2 raised to n outputs. So how many selection lines you have? I have the inputs, 1 inputs, 2 raised to n outputs, selection line, that will be equal to n. So it's just a reverse of a mouse. Another concept of an encoder. Encoder is a digital circuit that produces a binary output code depend on which its inputs are activated. So here, if you look at over here, so there are the 2 raised to n inputs and n outputs. Here, these are the enable inputs. That means whenever, if this block is not enabled, that means data will not forward it from input to output. Let us take the first example of 4 to 2 decoder. I told it's a 2 raised to n into n. So 2 raised to 2, that is a 4 to 2 encoder. So I have y3, y2, y1, y0, as an input and A1 and A0 as an output. So based upon the truth table, let's suppose if 0 0 0 1, output will be equal to 0 0. That means y0 0 0. If it is 0 0 1 0, it will be 0 1. That is, a y1 will be encoded to 0 1. y2 will be encoded with the 1 0 and y3 will be encoded with the 1 1. Based upon this a1 and a2, we can write a Boolean equation a1 equal to y3. That is a y3 here. a1 equal to y3 plus y2. This is a y3 and this is a y2. Same as a0, that will be equal to y1 and a0 will be equal to y3. So y3 plus y1. Based upon this, you can able to make a logic circuit. Same way, if you write the 8 to 3 here, the 8 to 3 is also octal to binary number. So I have a 8 number will be encoded into a 3 data outputs. So same way, what we had done in 4:2 encoder, we need to follow the same procedure for 8:3 also. So I have 0 0 0 0 0 0 0 1, that will be equal to 0 0 0. Look at somewhere it will fall like a 0 0 0. D4 equal to 1, that means 1 0 0. Based upon 3 y2 y1 and y0, will get, just you need to find a number of ones, and based upon ones you just this one, that is a d4. For this it will be d5 and d6 and d7. So add this number, so it will gives you y2. Same way y1 and y0, and make a combination logic circuit. So decoder is also like same as a encoder. That means what are the data you have encoded, now we need to decode it. So binary decoder is a multi-input, multi-output combinational circuits that convert binary codes of n input lines into one output of 2n output codes. Here, look at over here, 2n. Look at over here, it's n data inputs. What should be the output? 2n. It's all opposite to the encoder. Now take the example of the 2x4 decoder block, where I have the A and B as the input, D0, D1, D2 and D3 as the output. Now if it is 0 0, output that will be selected to D0 and rest of the output will remain 0. For example, here I told when till the enable block is 0, none of the input will go to the output, and it will be in the reset mode. When the enable is 1, that means 0 0, y0 will be 1 and rest of them are 0. If it is 1 0, that means y2 will be 1, rest of them are 0. Same way you can make the combinations of y0, y1, y2, y3. That means y0, where should be the 1, that is both are 0, that is a bar and a b bar. If it is 1 for a y1, it's a bar b. So you can write like this y2 and y3 and make a combination circuits over there. If you write a 3 to 8 decoder, same procedure, we have ABC as input, D0 to D7 as output. Look at the inputs and outputs, what we need. Let us take a one case to just explain you, like this case. If enable is 1, it's a 1, a 0 and 0. This is 4, that means y4 will be 1, rest of them are 0. Based upon this, you just make a equations and the combination logic circuit. Enable is must compulsory, remember these things. So this is the concept about the mux, demux and encoder and decoder. If you have any query, you just mail me on this my mail id sis.charola@marwadiyeducation.edu.in. Thank you, have a nice day.